ITC Gransee OG Season Rescue on Mars. We are the Robot Technology Club Gransee from Germany. We are students of classes 9 to 11. In our team are 6 students: Willi, Simon, Phil, Max, Gustav and Sebastian. Willi, Gustav and Simon were mainly involved with hardware and software. Max, Phil's and Sebastian's main task was 3D printing. Our idea is based on the Curiosity and Perseverance rovers landed by NASA. We have the big rover and the Curiosity. We also have a robotic stone. The large rover is the centerpiece of our performance. It has an Arduino Due and an Arduino Nano installed, a Raspberry Pi 4, a Zigbee module, a LiDAR sensor, LED stripes, a red board, servos, DC motors and a Pixie Cam. The Curiosity also has a range of components. It also has an Arduino Nano, DC motors, servos, the Raspberry Pi, a Zigbee module, a LiDAR sensor and a Pixie Cam. The stone is divided into 2 halves and each has the same components. These include the Arduino Nano, motors, the magnetic sensor and the Zigbee module. Our 4 features are the sensor system, the chassis, the human-to-machine communication and the machine-to-machine communication. Let's start with the sensors. Our robots are equipped with many sensors such as the Pixie Cam, which allows us to recognize colors. For example, if the robot recognizes the stone, it can align itself precisely with it. We've installed a micro-push button on our large rover. This detects whether the drone has returned to its starting position. A magnetic field sensor is installed in our stone. This recognizes whether the stone has been shot and then lets the second half to move off. We have also installed a LiDAR sensor in both rovers. This complements the Pixie Cam in alignment. And now the chassis. Our rover drives with a 6-wheel armored steering. This control system allows the Mars rover to turn in all directions without any problems. There's also a boogie axle at the rear and a normal sprung axle at the front. This arrangement allows it to drive over obstacles without any problems. Our machine-to-machine communication runs via Zigbee. Zigbee is a better alternative to Bluetooth. For example, you can control several robots with one signal, which saves a lot of code. It is also more reliable as few people use it and therefore there are no connection problems. It is also much faster than other options. This allows us to send signals to our robots simultaneously and at the same speed. The driving logic communicates with the motor via a serial port. Our human-to-machine communication consists of a Raspberry Pi 4 and a Matrix voice module. We train it on Raspi. Raspi learns the voice commands using machine learning. During the development phase, we had to deal with a few problems. For example, some of the parts that we designed in 3D didn't fit. That was partly due to inaccuracies in the measurements, which we subsequently rectified. Another problem was that not all wheels turned at the same speed. We programmed a PD controller to fix this. We determined the P and D values through several tests. We also had the problem that we couldn't always recognize whether the voice module was on or off. We therefore programmed the LED rings so that it lights up when it's ready. The Zigbee controllers and the voice module are innovative. These are not used by many teams. Our 3D printing is sustainable. The PLA from which the 3D printed parts are made of is made from cornstarch. This means that they are also completely biodegradable. During an exploration tour on Mars, Curiosity's drives failed and the rover drove inexorably towards a stone. Shortly before this impact, a call for help was sent. Since then, the NASA has been researching a rover for decades to free the little one from its hopeless situation. As they were not up to the task, they decided to ask us for help. After many years of research, we finally managed to build a perfect rover for the rescue mission. Today, his heroic rescue mission begins. The rover lands and makes its way to Curiosity. It shoots a stone in the process. The rover then searches for the small rover with its drone and refuels it with electricity so that it can move again. And that was our technical description video.